Alright, let's see if we can develop the laws for exponents with multiplication and division. I'm really a firm believer that you have to know why these laws and rules work, otherwise you really won't remember them for very long. And if you get into the middle of a test and you're stressed out, you're not going to be able to remember them as well anyway. So if you can work them out from scratch, it's much better. So remember that exponents are just shorthand for repeated multiplication. So when you see something like 2 to the power 3 times 2 to the power 4, remember the dot can represent multiplication. Just ask yourself, what is 2 to the power 3? It's just 3 2's, all multiplied by one another. And then 2 to the power 4 is just 4 2's. Again, all multiplied by one another. And if you look at this, it's just a series of 2's all being multiplied by one another. And so we can represent that using the exponent shorthand notation. There are 3 plus 4, 7 2's there. And so this can be written as 2 to the power of 7. So the law for multiplying when the bases are the same, this is crucial, the bases have to be the same, is simply keep the base and add the exponents. So let's use that for the one below. 5 squared to the power 2 times 5 without an exponent. Now, if a base or an integer doesn't have an exponent, it's the same as if it has an exponent of 1. Alright, because if you think about 5 to the power of 1, that just means take 1 5, multiply it by nothing really, so you just end up with 1 5. So if it helps you, put in the 1 so that you keep track of the exponents properly. So this is just simply 5 to the power of 2 plus 1, which is the same as 5 to the power of 3. And you can see that again if you take 5 to the power of 2 and just expand it, 5 times 5, and then times 1 more 5, you're going to have 3 5's. So this is our first law right here, and that one you will use quite frequently. Let's take a look at what happens with division. So I've got division, two examples, one written with a fraction, one written with a division symbol. They're both equivalent, really. So what is 3 to the power 6? It means you take that base 3 and you write it 6 times. So 1, 2, 3, 4, 5, 6. All of these 3's are being multiplied by one another in the numerator. In the denominator we have 4 3's. So we've got 1, 2, 3, 4. Well, we've seen how to reduce fractions like this. This 3 over 3 is just 1. It cancels out. Same with this 3 over 3. Same with this 3 over 3. And the same with this 3 over 3. So what are we left with here? We're left with just 2 3's on the top. And what's really on the bottom is a 1. Alright, so again, using the shorthand notation for multiplying, we can just write this with an exponent. 3 times 3 is just simply 3 squared. So how did we get 3 squared? Well, we had 6 of them on the top, we had 4 of them on the bottom, and for every one on the bottom you basically took away 1 from the top. So all we did was subtracted the exponent in the bottom from the exponent on the top. So this law can be written as b to the power of n minus m. And let's use that law to come up with the second one. Now, you don't have to write it as a fraction. You can just leave it the way it is and write it as 7 to the power of 5 minus 2, which gives you 7 to the power of 3.